Alright guys, so keep in mind that your entry task for today says to simplify the following. Now when you hear that word simplify, it's literally telling you just to make whatever problem you have look simpler. You're not solving for anything, you're just simplifying, trying to make it look a little bit more concise. Now, if I look at number 1, I notice that I have 2 something x. Now, does anybody remember what is going on when you have 2 things next to each other with no symbol, no mathematical operation in the middle? Which operation is it? Is it adding, subtracting, dividing, or multiplying? It's multiplying. So notice that all these guys, all the variables, all those numbers are just getting multiplied together. Now, when you hear multiplication, what you guys should be thinking of is the rules of exponents, because what are exponents at the end of the day? They're just repeated multiplication. Now, let's review that for a second. And this is literally all you have to know to pretty much review what we did yesterday. If I have 2 bases that are getting multiplied together, how can I simplify this in terms of their exponents? What do I do with their exponents? Do I add, subtract them, divide them? What do I do? You add them, absolutely right. Now keep in mind that your base stays exactly the same. In order to simplify that, all you have to do is add the exponents. And again, if you need a little more clarification as to why, make sure you go back and watch that video, and I go into a lot more detail why we add those exponents. As of today, you should be already to the level of like, okay, if I'm multiplying 2 like exponents or 2 like bases, I'm going to add their exponents. So let's go back to the problem. Notice that you're multiplying all these together. Now notice you have a 2 and a 4. Remember, they're just multiplying each other. So 2 times 4 is just a positive 8. That's what I like to do. Always start off with the coefficients, the numbers, the constants, because it's just multiplication facts at that point. Then I go back and then I look at my base, the first base that shows up, which is an x. And I ask myself, hey, am I multiplying by the like base anywhere? And I am, because there's an x over there. Now, does everybody remember what the exponent is if it's not there? It's a 1, right? So again, always go back to your mind and say, hey, I'm just multiplying a base times a base. My base stays the same, and I'm going to add their exponents. 3 plus 1 is a positive 4. So, and then you just keep going down. It's just a repeated process over and over. Notice you have a y. Is there another y? Yes. Now, what are you going to do to simplify those 2 y's that are multiplying together? You're going to add their exponents. 2 plus 4 is a positive 6. Now notice you have your z's, your base is going to stay the same. You're going to add their exponents, which equals a positive 7. You can always go back and double check. There's only 1 base of x, 1 of y, 1 of z. You can't combine any of these. 8 times x, there's nothing you can simplify. It's not going to equal b or c or 10. You can't multiply an x and a y to get something like a 3, a 5, or a y or something like that. You're pretty much all done. That's as simplified as it can get. Okay? Does that make sense? Okay. So, multiply 2 like bases, you add their exponents. Now let's go over here. Now the main thing that I want you to notice here is that it's a fraction. And a fraction is just a fancy way of showing multiplication. You're dividing what's on top with what's in the bottom. Now remember that when you divide 2 things that are the same, what does that equal? What's 5 divided by 5? Or, in this specific instance, what's 4 divided by 4? 1, right? 1 times anything is itself. So whenever you have these big monstrosity problems, just cross them out, because 1 times anything, you're going to be left with whatever's left over. Technically, they cancel out, but in the math world, you really don't want to say cancel out because they actually become something and then multiply something else. All right. Now, what I always like to do when I'm doing these division problems is just to write my fractions. So when I go through each of the variables, I'm going to place them wherever. Now, let's do a review back. When you divide 2 like bases, what do you do to their exponents? Because we know when we multiply, we add them. How about divide? What do we do? Throw a guess out there. There's only 4 things you can really do mathematically. Add, subtract, divide, and multiply. Which one is it? Subtract. Now keep in mind that where your base goes depends on where there are more bases. Notice that on the top you have 2. In the bottom, in the denominator, you have 3. So that means that you have more in the denominator. So your base is going to go to the denominator. And now you do the math. 3 minus 2 is a positive 1. I'm not going to write the 1 because it's a little unnecessary. And if you know that rule, you just repeat it over and over again. Notice you have 4 n's in the numerator, 2 n's in the denominator. There's more n's in the numerator. Now I have to do the math. 4 minus 2 is a positive 2. And you just keep going. There are 4 p's on top, 2 p's in the bottom. So that means you're going to have p's on top. And then 4 minus 2 is a positive 2. And that is all you have to do to simplify those ones. And that's everything that we did last week. Again, this is why it's kind of a little bit more straightforward, because there's really just 2 things you have to really concentrate on. Multiply two like bases, you add. Divide two like bases, you subtract. Now we're going to start adding to it. And this is where things are going to get a little bit more, I wouldn't say difficult, but they definitely get a little bit more messy. And that's our goal today, is to work through the mess. But before we go that, let's add two more additional properties of exponents. Now, there's one that's called the zero property. And the zero property has a very cool feature because it's actually really easy to deal with. Now, if we look at this one, notice we have a base of x getting divided by a base of x. Now, what do we do to the exponents again? Subtract them. So notice that our base stays the same. 10 minus 10 is 0. But wait a minute, what is x raised to the 0? Well, if we look at this side on the other side, what is something divided by itself? What is anything divided by itself? What is 5 divided by 5? 1. So what's x to the 10 divided by x to the 10? 1. So that means that we know, because we have something divided by itself, that it equals a 1. So what does this mean? If this is equal to this, that means that this is equal to this. So if anything that your heart desires is raised to 0, what should it equal? 1. It equals a positive 1. Not a 0, not anything. It doesn't just disappear. It becomes an actual 1. Notice that your bases disappear because anything raised to 0 equals 1. So that's a really nice property because it makes things actually quite simple. Now let's go to the next one over here. Now, when we divide two like bases, what do? Subtract. Absolutely right. Now, let's keep in mind what would happen if we, or where my base belongs. Now, I've shown you guys how to do it where your base is going to pretty much end up where you have more. So let's go ahead and do this. I know there's 5x's on top, 3x's at the bottom, so there's more x's on top. 5 minus 3 is a positive 2, so I know that x to the 5th divided by x to the 3 equals a positive 2. Now let's say if we were to work the other way around. Let's say that this time I would put my x in the denominator. Well, that means that you have to account for your subtraction. What is 3 minus 5? Negative 2. Absolutely right. So remember that whenever when you don't have a numerator, you want to put a 1, and I'm going to put a 1 over here just so that way you can see the fraction, so you can make the relation. Now notice that the math is correct on both the left and the right. Now what do you think we can do in terms of understanding negatives? Those two are equal. We did the math to the left and the right. We're right. Now what is a relationship that you think we can get from making those two moves? What is true about negative exponents? Look, come on guys, see what you guys see. Tell me what you guys see. Okay, where's your base in the first one? In the denominator. Where's the one in the second? In the numerator. What's the difference between their exponents?
One's negative, the other's positive.
Exactly right. So this is what is pretty much the property of negative exponents. If you have a negative exponent, it is really easy to make it a positive because literally all you have to do is move the base to the opposite side of the fraction. The action of moving it makes that exponent a positive. And it's about as straightforward as it gets. And you can work backwards, but 99% of the time there's no need to. If you have an exponent, if you move that to the bottom like you did, you can change the sign. But 99% of the time you're not going to do that. You're just going to deal with negative exponents. So the moral of the story that we're adding here is if you ever have anything raised to the 0, you could set it equal to 1 because anything raised to 0 is 1. Notice that if you have a negative exponent, in order to get rid of the negative exponent, you just move it to the opposite side of the fraction. The action of moving it makes it the opposite signs, which if it's negative, it's then going to be positive. And that's pretty much all that we're going to add to everything we've covered at the beginning, and hopefully everything goes well. All right, so notice that I gave you about 8 problems here. Try to do all these 8 problems. Remember the rules of exponents that I showed you guys. I'll be walking around trying to just clarify a little bit more if I can. You got it. All right, so let's go back and kind of start from the beginning. So these 8 problems really are to highlight the 0 property. And what's anything raised to 0? 1 equals 1. So if I have a base of 0 getting raised to the 1, what does it all equal? 1. Good job. So it doesn't matter if it's a variable. Let's say I have 1,000,000 raised to the 0. What's anything raised to 0? 1. So 1,000,000 raised to 0 is just 1. Now let's say that I have A times B times C times D, and it's all getting raised to the 0. What does all that getting raised to 0 equal? 1. Absolutely right. Let's look at this. Now remember, if there's no sign in the middle, what operation is it? Sorry? Times, absolutely. So this is 12 times x times y times z raised to the 0. Now keep in mind, what is all this garbage raised to the 0? What does that equal? 1. So this is 12 times the garbage, which we just found out equals 1. 12 times 1 is 12. A lot of students, what they like to do is when they see something raised to 0, they automatically like to just cross it out because it technically disappears. But there is times where that can get a little bit tricky, but it's very rare. But for the most part, that is something you could do. So this just equals a positive 12. And this is what I mean. Notice that A times B raised to 0. What's anything raised to 0? 1. So I like to cross it out and put the 1 there because then you can see negative 5 divided by 1 is just negative 5. Good job. Well, notice I have all this garbage raised to 0 divided by 8. What is all this garbage raised to the 0? 1. All right. Easy peasy. All right, so that's the 0 property. It's a little bit more straightforward. Now let's start dealing with the negatives here. So notice that I gave you another 6 problems to kind of try to just highlight that specific property. And then we're going to put it all together with the stuff that we did next week. So make sure that when you're looking at these problems, you're trying to see little things that are happening when I go from each problem that's going forward. All right, so just to review, if you ever have a negative exponent, you can deal with that negative exponent by moving it to the opposite side of the fraction and making that exponent a positive. Now keep in mind, on problems like number 1, I have a negative exponent, but I don't have a fraction. So that's why whenever I have a whole number and I know I'm dealing with a negative exponent like I do right there, I make it a fraction. I put a little line there that shows the division between the numerator and the denominator. And then I go back and I rethink, okay, what's the property? If I have a negative exponent, I can move the base to the opposite side of the fraction, and the action of moving it to the opposite side makes it a positive. So what is my base in this situation? Z. If I take that base and move it to the opposite side of the fraction, I'm going to show that by drawing another equal sign in a fraction. I'm going to move it to the opposite side, which would then be the denominator. And the action of actually moving it makes that exponent a positive, or really changes it to the opposite sign. Now that's cool and all, but notice I don't have a numerator. Now what do I put when there's no numerator?
1.
A 1. Yeah, that's absolutely right. So z to the negative 3 is the same thing as 1 over z to the 3. Now let's get a little bit tricky here, okay? Because notice I have 2 what a raised to negative 3. What does the 2 do into the a? Adding, subtracting, dividing, or multiplying? It's multiplying. So I know how to deal with the negative exponent. Let me write my fraction so that way I'm a little bit prepared when I do the work. Now, what is my base that has the negative? Is it the 2 or the a? The a. Remember when I said the whole spiel how there's attachment issues, right? That 2 isn't forever and never attached to that a. That's 2 times a. That 2 is not going anywhere. It's staying exactly where it's at. The a is the base with the negative exponent. So I'm going to move that to the opposite side. The action of moving it makes it a positive. So 2 times a to the negative 3, the same thing as 2 divided by a to the positive 3. Okay? Little tricky, but if you train your mind to see operations and knot them together, it'll be a lot better. And this is where another problem where it highlights that. Notice you have negative 6 times b to the negative 4. This negative 6 has its own exponent. It's getting raised to the 1. So that means when you're getting ready to move it, you're just moving the b to the opposite side of the fraction because it's the only one that has a negative exponent. The action of moving it makes it a positive. That negative 6 still has an exponent of 1. I'm going to leave it out just because I really just wrote it there to highlight that, hey, it's only the negative thing. Or the b is the only one with the negative exponent. All right, so let's check this out. Where's my base at? The denominator. Does it have a negative exponent? Yes. Now, it is improper to have negative exponents, so no matter what, your answer should always have a positive. How do we deal with it? We take that base and we move it to the opposite side. Now, notice it was in the numerator, or in the denominator. I'm going to move it to the numerator. I left out that 1 because 1 times anything is itself. It's really just, you could write it there right next to it, but it's a little unnecessary. Now, the action of moving it is going to make it to a positive. Now, do I really need a 1 in the numerator there? No, right? Because anything divided by 1 into itself, that 1 here is even kind of ugly there, so I'm just going to leave it as x squared. All right, so let's go to the next one. 10 divided by b to the negative 4. I notice I'm dividing by a b that has a negative exponent. Now, it's improper to have a negative exponent, so let's move it to the numerator. Now, my 10 is there just hanging out. My b is going to be moved to the top. The action of moving it makes my exponent a positive. Do I really need a 1 in the numerator? Denominator? Sorry. No. All right, last but not least, my negative 12 is hanging out on top. I can notice that my base has a negative exponent, so I'm going to move it to the numerator. The action of moving it makes my exponent a positive, so those two are equal now. So we spent about 12 problems highlighting both of them. Are you ready to kind of tie that into our last week? Nothing else you'd rather do, right? Okay. Now this is what I mean where things are starting to get piled up. They're simple concepts. You're just adding, subtracting, dividing, but there's so much things going on at once that it can get a little confusing. So that's why I purposely made these problems to kind of show you how to deal with which and where. The first thing you have to deal with, whenever you see repeated multiplication, do exactly what you did before. When you multiply two like bases, what do you do to the exponents? Well, guys, the extension task was number 1. When you multiply two like bases, what do you do to the exponents?
Add.
You add them. So your base stays exactly the same. What is 3 plus a negative 6?
Negative.
Negative 3. So notice that when I am repeated multiplication, I don't worry about the negative until the very, very end, which is what I have here. I have x raised to negative 3. Now, is it proper to have a negative exponent? No, but we know how to handle it. We're going to make this a fraction. We're going to move the base to the opposite side, which in this situation is the denominator. The action of moving it makes it a positive. Don't forget your 1 on top. Very, very kind of slow. We started with just doing something in the past with something we covered today. All right, so try number 16, 17. I'm going to press pause on the video and help you guys a little bit out there. All right, guys, so first things first is whenever you're dealing with negative exponents, there's a time and a place when you should worry about them first or at the very end of the problem. Now, whenever you're multiplying two like bases, like we are in number 6, 15, 16, and 17, do you see how we're multiplying two like bases? Don't worry about the exponents in terms of moving them to the opposite sides. Just deal with them like normal. When you're multiplying two like bases, the base stays the same, but you want to add the exponents. Negative 10 plus 3 is a negative 7. At the very end is when you want to start dealing with those negative exponents. Now remember that you need a fraction to kind of help. You don't need to, but it helps to see where your base goes. This is in the numerator. It's going to go in the denominator. The action of moving it makes it a positive. Don't forget your 1 on top because you need to have it so that way you can see that fraction. All right, cool? All right, let's go on to number 2. Number 17. 3 times n to the negative 5 times 2 times n to the negative 2. Again, this is just repeated multiplication. Yes, we have negative exponents, but don't worry about them when multiplying. Just do the multiplication. And let's start with the coefficients, the constants. What is 3 times 2? 6, right? Now we have the two like bases. When you multiply two like bases, what do you do to their exponents? You add them. Negative 5 plus a negative 2 is a negative 7. And now you can deal with that negative exponent. Here is my fraction. Again, notice that 6 has nothing to do with that negative exponent. Now, the n has a negative exponent, so it goes to the opposite side. The opposite side doing the action and moving it to the opposite side makes it a positive. Okay? All right, now let's look at these guys. Whenever you're dealing with division, you want to deal with the negative first because it becomes super confusing subtracting negative numbers. And this is what I mean by it. See how we are dividing two like bases? Before you start dealing with the negatives here, just get rid of the negative. So notice that this guy here has a negative 2. How do I get rid of that negative 2? I move it to the opposite side of the fraction. Now notice that this a to the 5th was just hanging out. So this a is going to move down. The action of moving it makes it a positive. Don't forget your 1 on the top side. Now notice, what are these two bases doing? Are they adding, subtracting, dividing, and multiplying? Multiplying, right? So what am I going to do to their exponents? Add them. So just to kind of highlight here again and to review, when you are multiplying like bases, just do the math. Do the adding the exponents and so forth. When you're dividing like bases, negative exponents, deal with the negative first because it makes it a lot more confusing than it needs to be. And let me show you how to do it in the next one. I notice that I'm dividing two like bases, but again, I have an exponent. So I'm going to deal with the negative exponent first. Now this b to the 4th is just hanging out, so there's your b to the 4th. I'm going to move this one to the top. The action of moving it to the top makes it a positive. Now I can clearly see here that I am multiplying two like bases, so what am I going to do to their exponents? Add them, right? So you end up with b to the 9 because 4 plus 5 is 9. Here I notice that I have 2 times x to the negative 2 divided by x to the 5. Now remember, do never ever start dealing with division with negative exponents. Get rid of the negative part first. Now this 2 has nothing to do with the x, just like we showed to the top. So this 2 stays on the top. This base stays exactly where it's at. I'm going to move this base down to make that exponent positive. And then I can clearly see here that I have 2 like bases getting multiplied together. What do I do to their exponents? I add 7. Okay? So you can see here how things are starting to get a little complicated at a time. But you guys will be all right. All right, so just for time's sake, I just want you guys to put your pencils down. Don't worry about writing notes here, because sometimes when I remember being a student, I would try to concentrate so much on writing notes down that I wasn't even really paying attention. So let's kind of just sit back, try to follow along, and see if, like, okay, I agree with this teacher or whatever he's saying each and every single step. All right, so I can notice here that I have 3 times x to the negative 5 and then divided by 2 times x to the negative 3. Now, before I even get started, I already know that I'm dividing two like bases that have negative exponents. Don't ever divide, because again, subtracting negatives gets a little bit weird. So let's get rid of the negatives. Now, is this 3 attached to that x? No, it's multiplying, so it's going to stay exactly where it's at. Now, notice that this 2 is going to stay exactly where it's at because it doesn't have a negative exponent. Now, what is going to happen to this x? I'm going to move it to the bottom because it has a negative exponent. The action of moving it makes it a positive. I'm going to move this base to the top because it has a negative exponent. The action of moving that one makes it a positive. Now, let's remember our rules. Can you divide 3 over 2 any way, shape, or form? No, you can't reduce it. You're dividing two like bases. Where are there more? The denominator or the numerator? Denominator. 5 minus 3 is a positive 2, so that is how you simplify that one. Again, you're doing a lot of the simplicity, but you got to make sure that you're building up those strategies. Notice you have a t to the negative 5. I'm going to move that to the bottom, make it a positive. You have a y to the negative 3. I'm going to move to the top, and I'm going to make it a positive. Can you divide a y and a t? Nope, so you're already moving on. Okay, so next one. This a is exactly where it needs to be. There's no negative exponent. I'm going to move this one to the bottom. The action moving it makes it a positive. Don't forget your 1 on top because it's a fraction. You're multiplying two like bases, so it becomes a to the 10. Don't forget that it's still 1 over. And that's pretty much all. And you'll notice that in the next one, we're going to add a little bit more and a little bit more. And at that point, I think that's about as far as we're going to get with the properties of exponents.